It's Mr. Benson here. I've got a short video that I'd like to show you on logarithms. Now logarithms are part of the level 10 advanced curriculum, so they're well and truly above the standard for year 9. But at the same time, they're not that difficult. So if you understand exponents, you should be fine to do logs. Also, I'm going to set about 2 hours work I think that you'd need to do to be able to answer everything on the test next week, and I'm going to try and have everything up online by Monday afternoon, so you have a chance to do that. If you have any problems or questions, just send me an email and I'll try and answer things for you. So firstly, having a look at why logarithms are useful. There are a couple of reasons. One of them is that logs, now let's get the pen, logs are the opposite operation to exponents. So one reason that they can be, or one way that they can be useful is to, there we go, excuse my scribbling, rearranging equations is one. So if you remember your order of operations, where you've got BODMAS, so it's brackets, order, or exponents, division, multiplication, addition and subtraction, whenever you're rearranging equations that involve exponents, you often need to use logs as part of that. Now the other thing is, the other time that logs come in very important is when you have what are called log scales. What is this pen doing? Now logarithmic scales are really useful for things that are either very big or very small, or change by really large amounts. So, for example, the Richter scale for earthquakes is an example of a log scale, because each number on the scale is a certain amount multiplied greater than the number before it. That's a terrible way of describing it. Another one that is important is sound intensity. So when people are talking about sounds being in decibels and stuff like that, logs are really useful for this. So the equation is L equals 10 log, and it's the intensity over the reference value. This is an equation that gets used in Year 12 physics. Now the reason logs are important here is sound intensities change by a huge amount. So the quietest sound that you hear is about a million times lower than a really loud sound like a jet engine or something like that. So the scale is a logarithmic one. So rather than having sounds that we say are like a billion times louder, they have just a smaller number to describe them. So that's a couple of things about why logs are useful, and now I want to show you a couple of things about what they are. Now hopefully you've seen from the previous video that logs are a lot like exponents. So with exponents, you hopefully used to the idea of something like, excuse me, modern technology. Rightio, got my pen back. Hopefully you used to the idea of having something like this. So 10 to the 3 equals 1,000. Where we've got a base and we've got an index, and so that's a way of expressing a number. Now logs are very much the same. Now logs have a base. Now often it's base 10, and sometimes when you see logs written, if you just see log by itself, it is the same as log base 10. Generally, if they're going to use a weird base, they'll write it. So say we wanted to log, I don't know, 5 of something, you would always write it like that, and you'd always see it like that. There is another kind of log that you'll come across if you do some kind of higher mathematics, which is it has a different base, and it's called the natural log. Often that is just written as ln. Now the base of that log is a number called e, which is a special number that you'll learn about later on. You don't have to worry about it at the moment. But on the whole, it all behaves in the same way. So logs have a base, and the value of, say, if I take the log base 10 of 1,000, is the exponent, which so if we had 10 to the power of that number, would give you 1,000. So you know that 1,000 is 10 to the 3. So we could write that again as log 10 to the power of 3. And so the exponent is the 3. So our answer is 3. Now, you can do this with, pretty much anything. So if I, we're going to do log base 10 of, 100,000, say. Again, all we're just going is how many powers of 10 are required to give this answer here. Now, we know, or you should be able to figure out from what we've done before, that 100,000 is 10 to the power of 5. So the exponent that we're dealing with is 5. So log base 10 of 100,000 equals 5. Now, generally speaking, when you're doing this, you just press the button on the calculator that says log, and it does it all for you. So that's pretty easy. But I'm going to show you some of the log laws, and they're basically the same idea as the index laws. And this is the kind of stuff that I'd like to see you be able to do. So I'll start off with a few of these, and then I'm going to put some stuff up online on Monday for you to have a go at. Okay, so log laws. So basically the log laws are a lot like the index laws. So if you think about it, our first index law was the multiplication law. So say we had 100, sorry, wrong button again. Say we had, no, I'll just get my pen. There we go. So we've got okay. This computer is now just annoying me. When in doubt, blame the computer. Right, there we go. Okay. My apologies. So 100 times 1,000. Now, as an index law, you know that this is 10 to the 2 times 10 to the 3, and we're just going to add those together. 10 to the 5. Now, if we have something like log of 100 times 1,000, now you pretty much could figure out what's going to happen here, because the you know that what's in the bracket here is the same as 10 to the 5, and so the log, and sorry I haven't written the 10 here, but remember that I said that if it doesn't have a base written next to it, it is log base 10. So you know that your answer there is going to be 5. But I want to break this down a little bit, and you'll see how the log law works. So let's break it up into our two factors here. So we've got, we got 10 to the 2, lost my bracket, times 10 to the 3. Now, what the way this works with logs, very much the way it does when you're adding the indexes or the indices together to get your final answer, is that we can actually add the logs. So it's log of 10 squared plus log of 10 cubed. And where's my cursor gone? So the log of 10 squared, we know that 2 is the exponent, so it's going to be 2, plus the log of 10 cubed is 3, and so we get 5 as our answer. So that's our first log law. When we've got the log of two factors multiplied together, it's equal to the log of one plus the log of the other. So if we're going to write that as a general law, we'll go log AB equals log A plus log B. Now, because you're all, bright maths geniuses and stuff like that, you will no doubt figure out what the second law is. So, you know that with indices, if I was going to do a division, so it's 10 to the 3 divided by 10 to the 2, then we subtracted the indices, got 10 to the 1. I'm not even going to show you an example because I think you'll get the idea that if we've got log A divided by B, we're not going to add the logs anymore, we're going to subtract them. So it's going to be log A minus log B. Now, actually, I've completely forgotten what the next index law is. So I'm just going to make it up and roll with it here, and you'll kind of get the idea. So I can't quite remember if this is the next index law or not, but say we've got 10 squared to the power of 3. Now, you know that that was going to equal 10 to the power of 6 because you multiplied the indices together. Now, with logs, it works in a similar way. Because what you're doing is, so if we're going to do this one, log of 10 squared, and that's all cubed. Now remember that 10 squared cubed is the same as log of 10 squared times 10 squared times 10 squared. Now, if we go back up to our first log law up here, you know that you're going to add those logs together, and so it's going to be log of 10 squared plus log 10 squared plus log of 10 squared. Now, I've got log 10 squared plus log 10 squared plus log 10 squared. I've got 3 of those, which is the same as 3 log 10 squared, and so the final answer I'm going to get here is 6. But there's something more important that you're seeing here. Log of 10 squared to the power of 3 is the same as 3 log 10 squared, and so there's a general form here where if we've got log of A to the power of B equals B times log of A. So there's the first 3 log laws. I'm going to put up a whole lot more stuff shortly. I'll work through some examples of these. So I'd like you to have a go at following through what I've done. Try and do some of the examples that I've put up. Feel free to email me if you've got questions, and if you spend a bit of time, probably 2-3 hours max on this through the holidays, you should be able to teach yourself all the stuff before the test on Tuesday.